Hey guys, Mr. Mackey here. Bit bright, sorry. Now, yesterday I was showing you how to use the gradient and the y-intercept to draw lines on a graph. And I set you a challenge yesterday to draw the line a half x minus 2. Now, let's go back over to the sheet of paper and let's see how the line should have looked. Let's do it. So, here is our axis, here is our equation. Now, do you remember which one's the x-axis and the y-axis? X-axis is along the corridor and the y-axis is up the stairs. Now, the first step is we have to find out what the gradient and the y-intercept are, and that's what the equation tells us. The number in front of the x, the half, is the gradient, or m, as the equation lifted. The -2 is the y-intercept, so the coordinate would be 0, -2. Now, when we start drawing these lines, I always start with the y-intercept, because if we're given a coordinate, might as well start with the one that we're given. So along the corridor 0 times, but we go down the stairs. So this is our y-intercept. Now, for all the other gradients we did, 2, 3, 5, what I was telling you is every x-axis we go across, every one we go across, we go up or down based on the gradient we have. It's still the same for this, except our gradient's a bit more difficult to follow because it's a half, meaning that every one we go across, we go up by a half. Now, think about this. What if we went across by 2? How far up would we go then? Well, if you go up by halfway for every one we go across, for every 2 we go across, we go up by 1, because that's a half, isn't it? So let me show you what I mean. So we start off at our y-intercept, and for every 2 we go across, we go up by 1. Every 2 we go across, we go up by 1. 2 we go across, up by 1. 2 we go across, up by 1. And we just continue. Eventually, it just becomes a bit of clockwork, doesn't it? Now, for some of you, you would have gone across by 1, then up by half, and you would have marked points there, there, there. I have no problem if you did that, because you still would have ended up with a very nice line. I'm just showing you a quicker method. Sometimes you don't always have to go across by 1 every time. Just go across so you ensure that you will go up by a whole number. So when you go the other way, across by 2, down by 1, 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 then carry on. And now the last thing you do is you get your ruler and you join all the points together. You need to line up. And there we go. That is how you do the equation y equals a half x minus 2. Awesome. So today we're going to stay downstairs because we're going to be doing something a little bit different. Now, I was showing you how to create lines by using the equations of lines. But what if you have to start with a line, but you need to find the equation of it? That's a good problem. Let's go and see how we can find the gradient and y-intercept from lines in a graph. Let's do it. So I have this equation right here. Well, I don't. I have a line and I need to find the equation for it. So, where's the best place to start? What do we need to find the equation? Well, we need to find the gradient. And we need to find the y-intercept. Now, the easiest one to find is our y-intercept, because we just need to find the coordinate that this line passes through the y-axis. The y-axis it passes through here. Do you know what that coordinate is? That coordinate is 0 and 0. So we've already found our y-intercept. So how do we find the gradient? Well, what we did in our previous example was we chose a coordinate and then we went for every certain amount across, it goes up by a certain amount. So let's do it for here. We need to find 2 whole number coordinates. So how about we go from there to there, making a triangle. So let's do da-da-da, da-da-da. Now, what I've done is for every one I've gone across, because I've spaced the coordinates out to make it a bit more visual. For every one I've gone across, I've gone up by 2 coordinates. So 1 to 2. What about for every 2 I go across? I go up by 4. For every 3 I go across, I go up by 6. What's happening every time? Well, for every x-axis I'm going across, my y-axis is being doubled, which means that our gradient is 2. So how do we write the equation? Well, it would be y equals 2x plus 0, but we don't need that 0. 0 just shouldn't be there. So the actual equation of our line is y equals 2x. So what about a line like this? Well, the first thing we're going to do is find our y-intercept. It passes through the coordinate 0 to 1. So that is our y-intercept. Take a note of that. Now, to find our gradient, I always like to start with the y-intercept, and let's go across by 1 coordinate. How far up or down does it go? Now, you've noticed that when we go across in this direction, we actually have to move downwards to meet the line again. Whenever we've had to move upwards, our gradient has always been positive. Now, because we have to move downwards in this case, our gradient is going to be negative. So when we move across by 1, we're going down by 1. When we're moving across by 2, we're going down by 2. Across by 3, down by 3. So what are we multiplying each time from our x coordinate to get to our y? Our gradient is negative 1. If it was positive 1, we would be moving up every time, but we're not. So another way you can tell that the gradient in this case is negative is when you do it in the opposite direction. When we move into the negative side, we're going up every time. It's positive when we have to move down in this area and up in this area. And it would be negative if we have to move up in this area and down in this area. If it's opposites, you have an opposite gradient. So the equation of this line would be y equals minus 1x plus 1. But we don't really need that 1 for the minus 1x because we've done that upstairs, remember? So y would equal minus x plus 1 or 1 minus x. It's pretty straightforward once you think about it. Let's do one more. So what about this line? Let's find our y-intercept first. Well, it passes through the coordinates 0 to 2. Now what about our gradient? Let's start off with our 0 to 2. For every 1 across, we end up going only halfway up. For every 2 across, we only go once up. For every 3 across, we go 3.5 places up. 4, we only go up 2 places. We're going up every time, which means that our gradient is going to be positive. But what is the gradient? Well, if every time we're moving up by 1, we're going up by only a half, our gradient is going to be a half. So our equation of a line is y equals a half x plus 2. Now I feel I've done enough examples on how to create lines and finding the gradients of them. So here is your challenge for today. For this, we're not going to have a line. For this, I'm only going to give you 2 pieces of information. And from this, I want you to find the equation of the line from that. Okay? I have the coordinates 0 to 3 and the coordinate 1 to 6. What is the equation of the line? Try and see how you do it. I want to see if you can try and find the equation of the line without needing to draw one. Let's see how you do. I'm intrigued what you're going to find. And a massive thank you to everyone who's been watching my videos, been sharing them. My videos have now become popular in Sweden. Like, I'm absolutely amazed by that. So massive thank you to anyone who's been sharing those videos in Sweden and in Canada. It's been such a nice feeling to be able to share these with people, to help people learn around the world in this circumstance because maths is important and it's good to keep track of it. So thank you so much for everyone who's been sharing it to help keep our children learning. Let's get cracking on the 2 coordinates. Let's see how you can find that equation. Good luck, guys. See you tomorrow.